For almost 100 years, modern science has told a remarkable story about the birth of everything. According to the prevailing cosmological model, the universe began around 13.8 billion years ago in a colossal event known as the Big Bang. But contrary to the common image of an explosion in empty space, the Big Bang was something far stranger. Space itself expanded. Time emerged. Matter and energy appeared. The laws of physics were born in conditions so extreme they challenge human imagination. Over the decades, this explanation became the backbone of cosmology. Evidence seemed overwhelming. Galaxies were moving apart, proving cosmic expansion. Ancient radiation known as the cosmic microwave background filled the universe like an echo from its earliest moments. The proportions of hydrogen and helium matched predictions almost perfectly. Yet one uncomfortable truth never disappeared. Scientists still could not answer the deepest questions. What caused the Big Bang? Why did it happen? And perhaps most mysteriously, what came before it? For generations, these questions remained beyond reach, hidden behind the limits of observation. But history has shown that every time humanity creates a more powerful telescope, the universe responds with surprises. And now, one machine is doing exactly that. The James Webb Space Telescope was built to see farther into space than any telescope before it. Unlike optical telescopes that rely mainly on visible light, Webb uses infrared technology capable of detecting ancient light stretched across billions of years of expansion. Looking farther into space means looking backward in time. Webb is effectively observing the universe as it existed shortly after its birth. Scientists expected groundbreaking discoveries. What they did not expect was confusion. As Webb began transmitting its first deep-field images, astronomers noticed something unsettling. The early universe appeared crowded with galaxies far more developed than theory predicted. Some galaxies looked massive despite existing incredibly early in cosmic history. Others appeared strangely organized, with structures resembling modern spiral galaxies instead of chaotic systems still under construction. According to standard models, the first galaxies should have been turbulent and irregular. Cosmic evolution was expected to be slow. Small structures were supposed to merge gradually over immense spans of time before becoming the giant galaxies we see today. But Webb's observations seemed to compress that timeline dramatically. Some galaxies looked mature far too early. And that created a problem. Had scientists underestimated how quickly galaxies formed? Or were parts of our understanding incomplete? The implications reach far beyond galaxies themselves. Modern cosmology depends on galaxy formation to reconstruct the history of the universe. If that timeline changes, it could affect ideas surrounding dark matter, dark energy, and even the behavior of gravity itself. Importantly, none of this means the Big Bang has been disproven. Science rarely collapses because of a single discovery. Instead, theories evolve. They adapt. They become more detailed as new evidence appears. Still, Webb's discoveries suggest the cosmic story may be far more complicated than previously imagined. And astronomy has experienced this before. The discovery of cosmic expansion shattered the old belief in a static universe. Dark matter emerged when galaxies moved in ways visible matter could not explain. Dark energy was proposed after scientists realized expansion itself is accelerating. Again and again, the universe forced humanity to rethink reality. Now Webb may be opening another chapter. To understand why Webb's discoveries matter so deeply, it helps to revisit the accepted story of cosmic evolution. According to current theory, the universe began in an unimaginably dense and hot state. In the earliest fraction of a second, something extraordinary occurred, a period called cosmic inflation. During this event, space expanded faster than the speed of light itself. Tiny quantum fluctuations were stretched across the cosmos, eventually becoming the seeds of galaxies, stars, and clusters. As the universe cooled, particles formed atoms. Gravity slowly gathered matter together. The first stars ignited. Galaxies emerged. And over billions of years, enormous cosmic structures filled the expanding universe. But modern cosmology also depends heavily on invisible ingredients. Dark matter, though never directly observed, appears necessary to explain the motion of galaxies and the formation of large-scale structures. Dark energy remains even more mysterious. Scientists can measure its effects, yet nobody truly understands what it is. Together, these unknown components are believed to make up most of the universe, while ordinary matter, everything humans can directly see, represents only a tiny fraction of reality. Now Webb's observations are forcing researchers to ask difficult questions. Could dark matter behave differently than expected? Did galaxies evolve through unknown mechanisms? Or might entirely new physics still be waiting to be discovered? Some scientists have explored alternative ideas, including modified gravity theories, cyclic universes, and models suggesting the cosmos may have existed long before the Big Bang itself. Most remain highly speculative. But their existence reflects something essential about science. Progress does not come from protecting assumptions. It comes from testing them. Perhaps the most profound lesson from Webb's discoveries is not that humanity was wrong, but that the universe remains far more mysterious than we imagined. Every generation believes it is approaching the edge of understanding. And every generation discovers new horizons beyond it. The James Webb Space Telescope represents one of humanity's greatest scientific achievements precisely because it expands those horizons. Behind every image lies decades of engineering, mathematics, and international collaboration. Scientists built machines capable of detecting light that traveled for billions of years across the cosmos. Through those faint signals, humanity is now witnessing ancient structures formed near the dawn of time itself. Yet perhaps Webb's greatest contribution is not the answers it provides, but the questions it creates. Could galaxies have formed earlier than expected? Are hidden chapters of cosmic history still waiting to be uncovered? Could our current understanding represent only the beginning of a much larger truth? The universe has repeatedly shown that reality is often stranger than imagination. Every discovery opens deeper mysteries. And perhaps that endless search is the true power of science. The willingness to question, to revise, and to continue exploring has carried humanity from staring at the night sky in wonder, to building instruments capable of observing the ancient universe itself. And if Webb has revealed anything so far, it may be this: despite everything humanity has learned, we may still be standing at the very beginning of understanding the cosmos.